Hi everyone, my name's Cary, and my talk today is titled Adding Context to Colors in Categorical Mapping. So today I'm going to start with a brief introduction and explain the term contextual congruence, which is the main topic around which this talk is built. And I will explain the two different types of contextual congruence, semantic resonance and affective resonance. And I'll then provide a brief summary of my plan to test these ideas this coming winter and some expected limitations and results. So when we add color to thematic maps using either the color schemes built into our tools such as ArcGIS or external color tools such as ColorBrewer, we have certain essential concerns, right? So we have the nature of the data, so we don't want to apply a sequential color scheme to categorical data. And we also have to think about how many data classes we have. So you have 5, 6, 7 classes, pretty easy. As you go up, it gets a little more complicated. So these are the essentials of color assignment. But what this can't do is take into account the actual context of your data. So what is your map actually about? And that's what I want to talk about today. So though it's important to have color assignment guidelines that work across map topics, I'm going to talk about matching color to the context of your data. So what are contextually congruent colors? Congruence is generally defined as agreement, harmony, balance, compatibility, and by context, I mean the what of a thematic map. So what's the topic? What's the story? And this can be either with regards to the individual components of a map or to the overall map as a whole. I define contextually congruent colors then as colors that are harmonious with the data context or the story being told by the map. So this relates closely to the congruence principle, which is typically discussed in the context of animation, but essentially says that the data and the design should be in harmony. And though these types are not necessarily mutually exclusive, it's useful to describe contextual color congruence in these two different parts, so semantically resonant and affectively resonant types. So semantic resonance is related to physical objects or otherwise well-established associations. It can typically be described using only hue. So for example, tomatoes are red, Twitter is blue. And affective resonance, on the other hand, is related to the sense of a color. So it often requires saturation or lightness to adequately describe. So an example would be lavender is calming, bright orange is cheerful. So starting now with a discussion of semantic resonance, how do the logical associations of color influence map interpretation? We know that when we significantly alter a map design, we alter its users' accuracy and efficiency. And we also know that despite the challenges and subjectivities involved, we continue to visualize data with graphics rather than, say, data tables, because visual perception is this so very efficient method of communication, and of course, because it's fun. Similar to point symbols, color assignments range in their closeness to matching the data which they are representing. So for example, when we color parks in green, we are more closely matching them to what they represent than if we were to color them in pink. So this idea of context-based color is not really new. I mean, in maps of physical data, we often use contextually relevant colors when it's convenient. So vegetation is green, soil is brown. But this has not really been empirically studied. So these two papers actually do study this, but they focus only on temperature maps, and their publication precedes recent developments in map design, such as web mapping. What we do know is that properly colored maps, particularly in terms of visual perception, increase map reader accuracy. So I'm proposing that the addition of context might increase that further as well. So there's a well-known phenomenon in psychology called the Stroop effect. Many of you may have heard of this. In essence, it's that people are slower and more error-prone when naming the colors of words when they're printed in discordant ink. So this is an example. If you were to try to name the color of the ink, it's not ink on a projector, I guess, but you would find the second group a lot more challenging than the first. And that's because there's this cognitive interference happening between the color of the word and the word itself. So your brain gets a little confused and has to slow down and really think about it. Similar effects have been found with other stimuli. So when people are asked to name objects in images. If the images are in a color that doesn't make sense, like a purple banana, people are slower to name that image. And the Stroop effect is proposed as a possible explanation for the results of this study in data visualization. In their study, Lin and others assigned semantically resonant colors to bar charts. So they used both a color assignment algorithm and the knowledge of a color design expert. And then they compared these with charts that just use the default Tableau categorical color palette. So still a legitimate color palette, but not matching to the data context. And what they found is that when participants used the charts with semantically resonant colors, so the second chart right there, participants were more efficient. They answered questions faster. So they suggest that this is because maybe of a Stroop effect or maybe because of less reliance on the legend. So colors have not just logical but also affective associations. So in this next section, I'm going to discuss how the emotional connotations of color might influence map interpretation. There's a significant amount of literature on the relationship between color and emotion, and actually most common are studies of hue, but the more strong correlations have been found in studies that use saturation and lightness. The idea of effectively appropriate colors is discussed quite a bit in marketing and consumer research, but has not, as far as I know, been really addressed in cartography. Maps and emotion, however, is a growing field in cartography, and effective media such as music and emotive art have been suggested as really promising tools for imbuing emotional qualities within our maps. And not only are the affective qualities of maps interesting in and of themselves, but emotion and cognition are also very interrelated. So when we learn more about the affective qualities of our maps, we actually also learn more about cognition in a way. We contribute to that research field. So there are a couple different frameworks we could use to discuss emotion, but I'm going to focus today on the core affect model onto which most human emotions can be mapped. So this model is comprised of two dimensions, which are called arousal and pleasure, and it can also be thought of as two different ranges. So the range from negative to positive, which is pretty intuitive, and a range from deactivation to activation. So this is required, for example, because if you consider happiness and contentment are both quite positive emotions, but happiness has a much higher level of activation, whereas contentment just sort of calm, still happy, but not the same. So in this recent paper, Bartram and others conducted three studies to identify color palettes that are expressive of particular affects. So these are 4 examples, but they actually had more than these. Color palettes were tested on bar charts and simple map type designs, which I'm hesitant to really call maps because they don't have a topic. Calm color palettes used more cool colors, high lightness, and low saturation. And as you can detect from this image, the exciting and positive palettes use warmer, more saturated colors. So kind of what we'd expect, but this is more empirical evidence of that. And one really important finding, as art has used color to display emotion for a long time, so one of the really important things coming out of this paper is that even small, perceptually distinct color palettes can carry emotional connotations. So even those types of palettes that we use in data visualization and in categorical maps. So taking this one step further, how does that interact with the data itself? So emotional response has been discussed in cartography. This paper used psychophysiological response measures as well as self-reports to measure people's affective responses to different color schemes and maps. So for example, this map I have highlighted was reported by participants as being shocking and strange, which is most likely because the water is red, which is kind of scary. I don't know why that would be. But I'm not really interested in measuring necessarily the affective response to maps, but more how the affective qualities of maps interact with the emotions and the data. So this paper is actually very relevant. So this is sort of a marketing consumer research paper. by Hans and others, and they measured affective qualities of car types. So they asked people for particular car types, and then they measured affective qualities of colors, and then different people they asked which colors are appropriate for which cars. And interestingly, they tend to correspond. So red is active, sports car is active, and then sports car is usually red. So this all kind of makes sense, but it's really cool that people have been testing this. So how do we apply this to maps? If you do just a simple Google search for thematic map, these are some of the results you'll find. And these are just the titles, but they all tell a story. So some of them are exciting maps of roller coasters or fun maps of TV series. Some of them are pretty emotionally neutral. This is just political boundaries in Canada. And some tell a story that's really sad or even frightening. So we can imagine that each of these map topics exists somewhere on that core affect model. So if we map that, it would look a little something like this. So since the affective color palettes identified earlier correspond pretty nicely with these, let's add those in. So this is essentially the launching point for the study I'll be conducting this winter. So a short discussion on that. I'll be conducting a two-part user study using Qualtrics and Mechanical Turk. Mechanical Turk is really gaining ground. I actually heard 2 talks this morning that used it, so learned a lot from that. And essentially, we're using Qualtrics to do the survey and questionnaire design, and Mechanical Turk is for participant recruitment and survey distribution. So in part 1, I'm going to focus on semantic resonance, and the goal is to measure whether SR maps are easier to read and which type of maps readers prefer. So for example, you can see in this first map, the colors match really nicely with the colors of fruit in the real world. The second map is equally fine in terms of color perception. They're the same exact colors. You have the same contrast, etc. But I've randomized the legend so that it's different. It doesn't match. So I also want to measure user preference because even if these are equivalent in terms of task efficiency, it might be relevant in many contexts that you want something that people enjoy reading. So the second part will focus on affective resonance. So still measuring these 2 first things, are AR maps easier to read and are they preferred? But also measuring what participants perceive to be as the emotional parts of these maps. So, for example, here is a map of childhood cancer, and I've used one of the really dark, negative, solemn color schemes identified in the literature to map this. So this is a really sad-looking map. It's obviously very sad data. I don't think anyone would argue with that. It's not political, it's just sad. But what if we change the color a little bit? So, yeah, see a reaction already. This is kind of like weird. This is, yeah. So this is what I want to know. So is this cheery color scheme like enough that it's really discordant, it's confusing enough to people that they're startled into slowing down or making mistakes when answering questions with this? Or does it at least change how the map feels to a person when they're looking at it? So there's a few different things that could happen. For example, I would expect mostly that people aren't going to like this. But there's another possibility, which is that this color scheme could sort of mitigate some of the negativity in the data. So you see those pharmaceutical commercials where they have the cheery color scheme and they read you that you're going to die. So maybe that's the same thing. I don't know. So we'll find out. This is the goal. So an increase in either efficiency or user preference at the end of this study would suggest benefits for the use in multiple mapping contexts. That's why we're doing this. And we know that color assignment in cartography is a very challenging balancing act even without these considerations. So even a negative result would suggest that cartographers could focus their efforts on other considerations. And lastly, some limitations. So participant responses might vary significantly based on individual preferences, spatial abilities. Some of these are possible to select out or, ask intro questions and then people don't qualify for the study, but some of this is just out of our control. And I also want to note that cultural variations in color connotations are not trivial. For example, red is very different in different countries and different cultures, and even within the US, people have very assorted cultural backgrounds. We're also starting from valid categorical color schemes in this, so I think this is reasonable at this stage of the research, but I do want to acknowledge that the study will not address some definitely foreseeable conflicts between color resonance and other color assignment considerations like visual impairment and color discriminability. So thank you.